So welcome to the another video in the compendium of limits. In this we are going to solve a problem that was asked in CMI 2022. So this is problem number A6, and it says that a function fx is defined as 1 upon modulus of ln x into 1 upon x plus cosine of x. Then we have to state whether these statements are true or false. So let's talk about statement 21. So first let's write the function fx equals to 1 upon ln x, and I'm gonna just multiply it, so this is 1 upon x plus of cos x upon modulus of ln x. Okay, so at infinity, at limit x tends to infinity, this thing 1 upon modulus of ln x cos x upon modulus of ln x, this thing at infinity, this thing tends to 0, and this thing in numerator it tends to -1 to 1, and in denominator it tends to infinity. Okay, so effectively this thing tends to 0, so the limit is 0, but we have to answer that the sign of it. Okay, so we know that what is infinity. Infinity is not any particular number, it is actually a set of numbers, an interval of numbers, and in that interval cos will lie from -1 to 1. So we can say that the sign of cos will change with various numbers. So statement 21 is actually true, that fx, sign of fx will change infinitely many times, because in any interval there are infinitely many numbers, and for infinitely many numbers the sign of cos will change. So statement 21 is true. Statement 22 says that at x tends to infinity the limit fx does not exist, which is a false statement, because at x because a constant upon infinity is 0, so the 0 and 0 add up to 0, so the at infinity the limit actually exists, and that is 0. Now statement 23, it says that at x tends to 1, so limit, I'm talking about statement 23, x tends to 1, and this is 1 upon modulus of ln x into x plus of cosine of x upon modulus of ln x. Okay, now at x tends to 1, this thing is actually this thing tends to 0, and because this tends to 0, so this whole thing tends to infinity. Okay, at x tends to 1, this also tends to infinity, so this whole limit tends to infinity. So at statement 23 is also a true statement. We can see that both tends to infinity, so because this tends to 0 also, and some constant upon something that is tending to 0 is actually tending to infinity. The statement 23 is also true. Statement 24 says that at x equals to 0 plus f of x tends to 1, so we can also find that, and that would be limit x tends to 0 plus f of x, that is 1 upon, and because we can see in graph of log this point is 1, so before 1, for every value of x in 0 to 1, log is negative, so we'll have a negative sign here, and this will, the modulus will open with a negative sign, and this is ln x into 1 upon x, okay, plus of cos x upon ln x. Okay, and we don't need to even write that, just finish it here only. Okay, now at x tends to 0 plus, okay, at x tends to 0 plus, where this goes, 0 plus means that you are somewhere here, and at x tends to 0 plus you go to minus infinity, so minus times minus infinity is actually plus infinity, it actually plus infinity, and that x at 0 at x tends to 0 plus, this goes to infinity, and this goes to 1, so this is actually infinity. So statement 24 is also incorrect. So we have just statement 21 and 23 are correct, and statement 24 and 22 are incorrect. So that's all, and that's about limits that was asked in CMI. So like, share and subscribe. Thank you.